Hi everyone, today we are going to cover chapter 2, Kinematics of Linear Motion. In this chapter we have 3 subtopics, so first of all we are going to cover 2.1, Linear Motion. Right, in this subtopic we have two types of quantities that you have learned in chapter 1. First of all, scalar quantity where it's only have magnitude, and vector quantity we have magnitude and direction. Okay, so the most basic quantity is length, right, for this chapter. So we have distance d and we have the displacement as the vector quantity. The symbol is s. Okay, so let's say we have 2 points, point A and point B. You take the long journey to reach B. You can also take the shortest journey from A to B, and then the longer journey that you take is called distance, and then the shortest distance we call it as displacement. So if we look at the actual meaning, the distance is the length of actual path between 2 points, and then this displacement is the distance between initial point and final position. To make it simple, is the shortest distance lah. Okay, and then from distance you can get speed. Okay, the symbol is v, and then from the displacement you can get velocity. The symbol is also v. Okay, now the meaning for the speed is the total distance, the rate of total distance travel. Meanwhile, velocity is the rate of change of displacement. Now we are going to look at the formula. Okay, the speed is equal to distance over time, and then the unit for distance is meter, the unit for time is second. So the unit for speed is meter per second. So for velocity is displacement over time, where the unit for displacement is also meter, and then the time is second, so the final unit is meter per second. And from velocity you can get acceleration. Okay, so acceleration, the symbol is a, and then the acceleration is the rate of change of velocity. So a is equal to velocity over time. We know already that velocity is meter per second in unit and time is second. So when we combine, the final unit will be meter per second square. Now let's look at the example here. An insect crawls along the edge of a rectangular swimming pool of length 27 times 21. It crawls from A to B in 30 minutes. So question A, what is average speed? We know already just now, speed is equal to distance over time, right? So the distance from A to B, you need to calculate the actual journey, which is 27 plus 21. Okay, over time. Time in 30 minutes. So the minute you need to change to second because we need everything in SI unit. So the final unit is meter per second. And then for B, what is the magnitude of its average velocity? So velocity is equal to displacement over time. The displacement is the shortest distance, kan? The distance from initial to final. So we have triangle here. So how to find the A to B hypotenuse? So we are going to use theorem Pythagoras. So 27 square plus 21 square, square root answer, and then you get the displacement from A to B. So you substitute inside the displacement and then times 30 times 60, and then you get the answer in meter per second as well. Very easy, very straightforward. Next, we are going to learn about 2.2, uniformly accelerated motion. So in this subtopics, we have 3 important equations that you need to know, you need to remember. So we have V as the final velocity, U is initial velocity, A is acceleration, T is time taken, and S is the displacement. Okay, so we have S, we have T, we have A, we have U, and you have V. Okay, and then it will just repeat it lah. Need to know which equations to use. So example 6, a plane lands on a runway at a velocity 50 meter per second and decelerate at constant rate. So we have U, initial velocity, and decelerate mean acceleration lah. Okay, but we don't know. And then we have the displacement, travels 1 km. Right, calculate the deceleration of the plane. So A is what we want to find. So remember that we have three equations. I write it again. Plus 2as s is equal to ut plus half at square. So we need to determine which equations to use. Okay, so they ask you the A. Do we have each information? Okay, we have u, we have s, and then before stops. That means the final velocity is 0. So we have u, s, and v. So can we use the first one? We have v, we have u. Do we have a? No. We have t? No, we don't have t as well. So we cannot use because we have two unknowns. Let's look at the second equation. We have v, we have u, we don't have the a, but we have the s. So yes, we can use the second equation. So v square is equal to u square plus 2as. V is 0, square is equal to 50 square plus 2. We want to find the a. S is 1 kilometer. You need to change to meter. Okay, and then you do your maths and then you get the answer in meter per second square. For B, the time taken for the plane to stop. So this one they ask you the t. So can we use the first? We have v, we have u, we have the a from a. We don't have the t, so we use the first equation, the simplest one. 0, 50 plus, and then masukkan t, we don't have. And then do your maths again, and then you get the answer in second. Very easy. Okay, next we are going to enter 2.3 projectile motion. So this one is a little bit crucial because you don't learn this in school before. So in projectile motion we have three cases. Okay, for case 1, let's say we have a stage and then we have a ball on the stage, and then when you kick the ball, it will fall in that motion. For case 2, let's say the ball is on the ground and then you kick the ball and then it will experience that motion. And then for case 3, we have a stage again, and then we have the ball on the stage, and then when we kick it, it will go upward first and then it will fall in projectile motion. Okay, so there are several things that you need to know. Okay, untuk case 1, we have the initial velocity u, and then we have the vertical displacement, we have the horizontal displacement, and then for case 2 we have horizontal displacement, then we have the height or the vertical displacement, we have the angle, and then we have the initial velocity u. And then for case 3, okay, we have the same thing. We have the height of the stage, and then we have the horizontal displacement, we have the vertical displacement sy, and then we have the angle, and then we have the initial velocity as well. Case 3 is a little bit complicated, but it's okay. And to solve the projectile motion, we need to use the three equations that we have learned previously. So I write this again. And before this, we have learned to solve just one component, but for projectile motion, you need to use both x and y component to solve. So there's a thing that you need to know to solve projectile motion. Okay, you need to know that the acceleration due to gravity, or ay, is equal to negative 9.81 meter per second, and ax is 0 because gravity is only happening in y component, and y is negative because it's always acting downward. Right, so let's do example 8. A cannonball is fired with an initial velocity of 30 and angle 35 to the horizontal. So let's draw lah so that you can see clearly. So we have a ground and cannonball, and you are given the u. So u is 30 meter per second, and then the angle is 35 to the horizontal. Now the question is, what is the maximum height reached by the ball? So they ask you to find the sy, or the vertical displacement. Right, so again, like I've mentioned before, we need to use the equations, the three equations that we have learned. So s is equal to ut plus half at square, right? Okay, we need to choose which equation to use. So let's look at the first equation. Can we use it? Right, they asked you to find the s, so we don't have the s in the first equation, so that was out of option. We only have the second or third. Right, can we use the second? Let's look. Okay, there's one thing that I forgot to mention. In projectile motion, the velocity experienced by the ball is like this. Okay, and this is u, and then this is the velocity, and then this is the final velocity. So at the center, at the top position, at the height, maximum height, the velocity is to the right. So it's only in x component. So our Vy is literally 0. Okay, so the Vy on the top of the motion is 0. Right, so this is, okay, Vy equal to 0. So let's look, either we can use the second equation. So we will try and error. So we know that if you want to find the sy, everything need to be y as well. Vy, uy, ay, and sy. So we know that Vy is 0 at the top, and the uy is, right, for this one we need to find a separate place. U given is only resultant u. You need to resolve it, ux and uy. So you have learned in school before that the center is u, the resultant u is u, and then horizontally ux, uy, and the vertical, and the angle is 35. So you need to resolve. To find the uy, you need to use 30 sine 35 square plus 2, and then ay is negative 9.81, I have mentioned before, and then sy. So you do your maths, and then you get the answer in meter. Okay, and for B, what is the horizontal range? Horizontal range is the horizontal displacement, which is sx. And again, we need to choose which equation to use this time. Since we know that we are finding the s, so the first equation cannot be used because there's no s in the formula. It's either the second or third. So let's look at the second. The v, the final velocity, is actually not 0. So, but we don't know what is it. So it is still unknown, and s is unknown as well. So there's two unknown that we cannot use. So we only left with the third equation, which is s is equal to ut plus half at square. And again, when we want to find the x, everything need to be x, ux, ax. T don't have the component. Okay, we just let it be. And again, I repeat this again, ay is negative 9.81 and ax is 0. So you can cancel out the half axt square because it was literally 0. So what's left is sx is equal to uxt. We need to find the ux using the same concept just now. We know that uy is u sine theta, so ux is u cos theta. So 30 cos 35, and then t, we don't have the t, but since we have no other choice, we need to find the t. Okay, in projectile motion, the whole journey is divided into two parts, and the first and second half parts is symmetrical. So we only have the information in the first half, where our Vy on the top of the motion is 0. So let's use that in our equation. So we are finding the t. I'm using the first equation because that was the simplest. The second one cannot be used because we don't have the t. Okay, I'm using v is equal to u plus at. And since we only have the Vy information, so I'm using the y, uy, ay. So Vy is 0. And the uy is 30 sine 35. 30 sine 35 plus negative 9.81 t. Because we are finding the t. So from this, you can find the time for the first half of the projectile motion. So to find the final, the whole journey, the time taken for the whole journey, you need to times by 2. So 2t is equal to 2 times the answer that you get from the top lah. Okay, so you get the time in second, and you substitute the value in the SX equations, and then you get the answer something in the unit of meter. That's it.